Hello everyone, Mr. John here from Areteem Institute with this week's Thursday Tidbit, where we're going to be introducing correlation, causation, and talking a little bit about prediction that way as well. So, jumping into the main idea here. We're given some data and we want to examine the relationship between those data sets. So as an example here, suppose we want to ask the question, is there a relationship between age and the height? So this is a pretty simple example, but we see here kind of these quantities and we want to ask about a relationship between them. Now, at the moment, this is a pretty vague question. So let's look at some data and see what details we might want to include. So, for example, what if we want to specifically look at age versus height for US males, and let's do age 0 to 10. So, if we're talking about data, we might want to organize it in different ways. So, for example, we could look at the data here in a chart. So we have the age in years. So we could say, okay, we have a 0, 1, 2, 3, all the way up to age 10. So we're comparing our kids from age 0 to 10. And we're comparing that to their height then in inches. So we have all the different heights here, right, ranging from the height around 20 inches when they are born, all the way up to about 54 inches when they are age 10 in this case. Now, especially for comparing these things, a visual idea or a visual picture is helpful too. So if we look at that same data in terms of a chart, we have this chart there. And now we want to start asking these questions about, well, is there a relationship? And I want to introduce some vocabulary words in this case too. First of which is correlation. This is a word mainly you'll see in statistics, but it can be used a little bit more generally as well. Right? We have correlated data sets, or there's a correlation between things. So here our things might be age and height. And we say they're correlated if there is a relationship. Typically, if you're doing actual statistics, you're talking about a linear relationship between them. And you can clarify the direction of that relationship. If, right, we're talking about numerical things, it's a positive correlation when one quantity increases, the other increases, and it's a negative correlation if one goes up, the other goes down. So if you're talking about proportions or things like that, this could be a direct proportion, an inverse proportion, things like that as well. And so this is just talking about the relationship between those numbers. Now, causation is if one outcome is the result of the other. Now this is a little bit trickier, but let me highlight this word result here. And it's probably easiest, I know you're not supposed to define words with the exact same word, but right, this is really one event or one thing causes another. Then we have this idea of causation in that scenario. Now, the normal phrase you'll hear all of the time, which we're exploring a little bit in this case, is that correlation is not the same as causation. And I want to stress here that correlation is a mathematical thing. Especially if you're doing linear relationships, you can study these with statistics. So if you've taken some statistics, you'll have things like correlation coefficients, which is a measure of how well correlated they are, or things like that, right? And you typically want to use these correlations to say, oh, we have this nice relationship, we know that they are correlated, and then we might want to use that data to make predictions of future outcomes. And I just want to stress here that causation cannot be determined mathematically, right? These things are more, maybe if you want to say physics or real world sciencey things. Does one thing cause another? And you might have to worry about measuring that or things like that. But this is more of a why. So the causation is, oh, if they're caused by one thing, you might want to know why that's the case. Correlation is purely the mathematical relationship between the two. So if two things are correlated, it does not mean that one thing is caused by the other. Now, let's look at our age versus height, right? So we have this graph here in this case. And if we look at whether these are correlated, a lot of the times you will see these linear lines drawn, right? So we want to say, okay, like we have this line here, if we do a line of best fit or things like that, we probably would say that yes, these are correlated. So we do have a correlation between the age and the height. Now, causation here is a little bit trickier. I'm going to put yes with a question mark here, right? These things are a little bit more up for debate in that way. My justification for yes would be if you have two kids, one's taller than the other, and somebody asks you, right, say they're siblings. Why is this one taller than the other? You might say, oh, that's because he's older. So I don't want to argue too much about, okay, does age cause the growth or things like that? Maybe, maybe not. But in this case, right, if we can say because, right, they're taller because they're older for the kids growing and things like that, you could maybe argue that the one is caused by the other in that case. Now, there's lots of good examples. Maybe we'll see some more next week of things that are correlated but not caused by the other two. But we want to explore this a little bit more and some things about our predictions with the following inspiration for this video. So, little background, football, National Football League, NFL games. They start with a coin toss. The winner of the toss gets to decide if they want the ball first, right? The details there are a little bit more complicated. You can decide whether you want the ball now or if you want it maybe in the start of the second half, or you can pick which side of the field you want. But roughly speaking, the winner of this toss gets to decide some information about what's going to happen at the beginning of the game. Final game, right, it's called the Super Bowl in this case. And so let's look at the following piece of data, or the following data set, if you like. So during the last 8 Super Bowls, the winner of the coin toss has lost the game each time. So this is a slightly interesting thing there, right? So the winner of the coin toss has lost the game each time in those past 8 years. So, right, this is, based on this data, this is definitely a correlation, right? We actually have every single time they won the coin toss, they lost the game each time. So, getting into our questions to think about for next week. And we will expand on this a little bit more. But here we have an example of a definite correlation. And you might want to think about causation there a little bit. But our question is, starting with the Super Bowl, for next year's Super Bowl, do you think that the winner of the coin toss is less likely to win the game? Remember, over the last 8 years, the winner of the coin toss has lost every single game. And justify or think about some of these correlation, causation things when you're making this prediction. Now, based on the age versus height data as well that we had earlier in this, can you predict the height of a 12-year-old, a 30-year-old? Again, explain why or why not here. We maybe don't care too much about the actual numbers from that data, but right, yes or no, could we use the data to make a good prediction? Now, think about how, right, additional information might be helpful, what information might be helpful, but also why additional information might be helpful. In a way, these two questions about totally different things are somewhat related to each other. So try to think about that, and we will discuss that in next week's video too. Real quickly, I want to give a source for the heights of those US males that they were retrieved from this website right here. Otherwise, thanks for watching. If you like this video, give it a like, subscribe, really helps us out. And otherwise, share your ideas for new topics and stay tuned for answering of some of these questions from the previous slides in next week's video. Goodbye.